Let's look at our very first calculation example together. Look at the question on your screen. A wire with an initial length of 5 meters is heated from an initial temperature of 10 degrees Celsius up to a final temperature of 60 degrees Celsius. We are told that it undergoes a change in length of 20 millimeters. Our goal is to find the linear expansivity of this wire. Before we do any math, we must notice a major trap. The change in length is given in millimeters, but standard scientific SI units require meters. To convert 20 millimeters into meters, we divide it by 1000, which gives us 0.02 meters. Next, let's find our change in temperature, delta T. We take the final temperature of 60 degrees and subtract the initial 10 degrees, giving us a temperature change of 50 Celsius. We can express this as 50 Kelvin since our linear expansivity is given as per Kelvin. Now let's bring out our golden formula for linear expansivity. Alpha equals the change in length divided by the product of the initial length and the change in temperature. Let's substitute our values into the formula. On top, we have 0.02 for the change in length. On the bottom, we multiply our initial length of 5 by our temperature change of 50. 5 times 50 equals 250. So our fraction becomes 0.02 divided by 250. When you compute this division, you get 0.00008. To write this cleanly in standard scientific notation, we move the decimal place 5 steps to the right, giving us 8 times 10 to the power of -5 per Kelvin. Looking back at our options, this perfectly matches option C, 8 times 10 to the power of -5 per Kelvin. In our next video, we will take our second example.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.